This is 11-8 Day 1 notes. So at the top we're just going to recall and remember a couple things. First, let's look at 4x plus 4y. Well, how do we factor this? What can we do? First thing we always check for is the GCF. So is there anything I can take out of 4x and 4y? Yes, there is. I can take out a 4. So that means my GCF of this problem is 4. And let's finish factoring it. We put our GCF down here, and then what's left? Well, the 4's cancel, and I'm left with x, plus the 4's cancel, and I'm left with y. Can we factor x plus y any further? No, we can't, so we're done. So don't forget, at the beginning of every problem, we always ask ourselves if there's a GCF. Now let's try this one. We have 2x times x plus 4 minus 3 times x plus 4. This type of problem should look familiar. We've done several of these in class. Look at both terms. What do they both have in common? They both have that x plus 4. So actually, in this case, that's what our GCF is, the x plus 4. Well, now we're going to divide both sides by that GCF. And what happens? X plus 4 over x plus 4 cancels, and we're left with 2x. Over here, x plus 4 over x plus 4 cancels, and we're left with negative 3. So we take out our GCF, and then we group together our leftovers. We're left with 2x minus 3. One more problem like that. I want you to pause the video and try it. All right, now that you've tried it, what do they both have in common? They both have that y minus 2. So I'm going to divide both sides by the y minus 2. Over here, the y minus 2's cancel, and we're left with 3y squared. This one looks a little different because they cancel, but what am I still left with? Y minus 2 over y minus 2 is 1. So I am left with a plus 1. And that is super important that you don't forget that plus 1. So that's what we need. These are the tools that we will need today for factor by grouping, and that's why we wanted to recall them. So this is one of our last methods of factoring, and it's grouping. And let's just look at how to do it together. Here's our example, 2x plus x cubed plus 2 plus x squared. The first step is always going to be standard form. We need to take this polynomial and put it in standard form. Well, that means that x cubed needs to go first. Then we take the plus x squared, then plus 2x, then plus 2. Remember, standard form means we have the highest degree first. So we must have standard form. Well, that's good. Next one, group the first two terms and the last two terms. So x cubed and x squared, we're going to group them together. Then 2x and 2, we're going to group them together. So that one is done. Notice here that we are still adding these, so we're not multiplying these two sets of parentheses. We are still adding. Step 3, factor the GCF out of both groups. So let's look at this. X cubed plus x squared. What can I take out of both x cubed and x squared? Well, they both have x's, so we take the lowest exponent, which is x squared. So that's our GCF of just this set of parentheses. So bring down your GCF. Well, what's left? When I take out an x squared from x cubed, remember we subtract the exponents. That 3 minus 2 leaves me with x. Then x squared over x squared, that gives me 1. So GCF was taken out of the first set of parentheses. Now we're going to bring down that plus sign, and we need our GCF of this second set. Well, what can we take out of 2x and 2? We can take out a 2. So bring down that GCF. Now 2x over 2, the 2's cancel, and we're just left with x, plus 2 over 2 gives us 1. So that was the next step. Factor out the GCF of both groups. That's done. Now look at this. Again, this should look familiar. It's a lot like these problems above. What do you notice about both? They both have this x plus 1, x plus 1. Whenever you do factor by grouping, you will end up with these common parentheses. If not, then you most likely did something wrong. So we've got to have a common factor. So step 4 says write down the common factor in parentheses. What's the common factor here? It is x plus 1. That's what they both have, x plus 1. Well, then what's our next step? Write down the leftovers in parentheses. So what's left over here is x squared plus 2. We write down the common factor, x plus 1, then bring together those leftovers, x squared plus 2. So we're good on that one. This last step is important. We need to check for differences of perfect squares in the factors. So we should know that differences of perfect squares are something kind of like x squared minus 16. That's an example. X squared is a perfect square. It's x times x. 16 is a perfect square. It's 4 times 4. So we can actually factor that further to be x plus 4 and x minus 4. And again, that's just a random example. So always look for difference of squares. X squared is a perfect square, but what's wrong with this? This is not a difference, so we actually cannot go further. And in addition to that, 2 is not a perfect square. So now we are finished. But what do we always do before saying we're done? We need to check our work. So I'm going to have x times x squared will give me x cubed. Then 1 times 2 will give me a positive 2. The inner product, 1 times x squared, will give me x squared. And the outer product, 2 times x, will give me 2x. Is this the problem we started with? Yes, it is. So our answer is correct. Always check your work. Well, we're just going to practice this. So our instructions are factor completely. Here we go. Problem number 1. Let's do x cubed minus 2x squared minus 9x plus 18. First, we check all 4 terms. Is there anything we can take out of every single term? A GCF here? No, there's not. So, next thing we check, is it in standard form? Yes, we have x cubed, x squared, x, and constant term. So now we need to group. We're going to group together our first terms. And notice this one has a negative 9x. You've got to group that negative in with those. But when you do that, go ahead and draw a little plus sign between them. Because we are not multiplying these polynomials. We are still adding the negative 9x plus the 18. So we've got to have that plus sign in between. So that was our first step, was grouping. Now, what does it say above here? That after we group, then we factor out the GCF of both groups. So x cubed minus 2x squared. What can I take out of both of those? I can take out an x squared. So that's my GCF of this first set. Well, x cubed divided by x squared, we subtract the exponents and get x. And then these x squareds cancel and I have minus 2. We'll bring down that plus sign. Now, negative 9x plus 18. What do we notice about our leading coefficient? It is negative. So that means our GCF has to be negative. Well, what else can I take out of these parentheses, out of the 9x and the 18? They are both divisible by 9. So I'm going to take out a negative 9 and a negative 9 and bring that down here. Well, I have plus a negative 9. Another way to write that is by just writing minus 9, because plus negative 9 is the same thing as minus 9. Well, there's our GCF, minus 9, and then what's left over? The 9's and the negatives cancel, so we have x, and 18 over negative 9 is negative 2. One thing you need to always check here, do our parentheses match? Yes, they do. So now we take out our common factor, x minus 2, and we group together our leftovers, x squared minus 9. All right, last step, check for differences of perfect squares. Well, x minus 2, x is not a perfect square, so that one's done. X squared is a perfect square. We have a difference. 9 is a perfect square as well. So we know that to get x squared, that's x times x. We know to get 9, that's 3 times 3. So we can actually go further with this set of parentheses. This is a difference of squares because we have a minus sign and we have 2 perfect squares. So when that happens, you bring down this other factor. We didn't do anything to x minus 2. X squared minus 9. How can we factor that? Well, we know a difference of squares is going to be x plus 3, x minus 3, because we have x times x and 3 times 3, so 1 plus. And real quick, we'll check again. Do we have any other perfect squares? No, we don't. So that is our answer. All right, second one. We have y cubed minus 9y squared plus y minus 9. I want you to pause the video and try it and then check your work. All right, it is in standard form and there's no GCF. So now we just start grouping. Well, what can I take out of this first set of parentheses? I can take out a y squared. So that's my GCF. And now what's left? Y cubed over y squared is y. These y squareds cancel and we have 9. Now what about this one? Y minus 9. Is there any GCF there? No, there's nothing that they share. So actually we can just bring out a 1, or in other words, no GCF. All we could take from both of those is a 1. But I'm going to go ahead and write that down because that'll help us in a second. All right, next thing we do, common factor. Make sure those parentheses match. If they don't match, that means we made a mistake earlier. But these match, so I bring down my common factor, and then we group together our leftovers, y squared plus 1. And this is where it's really important to realize that there's a 1 there, because if you just have a y squared, that doesn't actually finish off this factor. That is our full factor, y squared plus 1. Next thing we do is check for difference of squares. Y minus 9, well, y is not squared, so that's not a perfect square. Y squared is a perfect square, and actually 1 is also a perfect square. But what's wrong with this one? It's a plus sign. So if you went ahead and factored this further, I hope you see now that we can't do that. It's not a difference of squares. This is a plus sign. So we can't do that. We can't go any further. So we're done. Let's look at number 3. Number 3, we have 8m cubed minus 16m squared minus 2m plus 4. What's the first thing we ask ourselves every single time? Is there a GCF? Yes, there is. What can I take out of all of these? I can take out a 2. Every single one is divisible by 2. So bring down that 2. 8m cubed divided by 2 will give us 4m cubed. Negative 16m squared divided by 2 will give us negative 8m squared. The 2's cancel and we're left with negative m, and 4 over 2 is 2. Now that we took out our GCF and we see it's in standard form, we're going to group. So I'm actually going to group them like this time, since we already have parentheses. And again, remember, when that's a minus, you need to take the minus, and there is a plus sign in between those. Okay, same process that we have been doing. What can we take out of 4m cubed and negative 8m squared? We can take out of both of those a 4m squared. So we'll bring down that 4m squared. For now, leave the GCF. We will bring it down later. So I'm taking a 4m squared out of both of these, and then what are we left with? Those 4's cancel. M cubed over m squared is m, and then negative 2, the m's squareds cancel. So that was my GCF of this first section. Now we grouped these two terms together. What do we notice about the leading coefficient? It is negative, so we have to bring out a negative for our GCF. Well, is there anything else that we can bring out of m and 2? No. So that means our GCF is just negative 1. So bring down the GCF, and then when I divide them both by negative 1, what am I left with? M minus 2. So make sure your parentheses match. That's our common factor. So we're going to bring out our common factor, m minus 2. Then what's left? Group our leftovers. 4m squared minus 1. What am I missing from this answer right now? I'm missing that 2. And then last thing we need to do is check for difference of squares. Well, 2 is just the GCF. M minus 2 is not a difference of squares, but 4m squared minus 1 is. 4 is 2 times 2. M squared is m times m. That is a difference, and 1 is 1 times 1. So bring down the 2 and the m minus 2, and then what are we going to have in these two? This is a difference of squares, so we'll have 1 plus, 1 minus. To get 4m squared, we do 2m times 2m, and to get that negative 1, we do a 1 and a 1. So that is our answer.